Today, we're going to talk about the squeeze theorem. The squeeze theorem is a method of evaluating limits where you take a limit that you don't know and you squeeze it between two limits that you do know to force an answer. So I have a function f of x and a function h of x. Now suppose for all x that f of x is greater than or equal to h of x, like so. But what if we introduce a new function g of x in the middle, like so? And we know that g of x is always between h of x and f of x. Now let's imagine that we know that the limit as x approaches c of f of x is L, and the limit as x approaches c of h of x is also L. So we know that this equation is true. But if we take the limit as x goes to c of this inequality, then we see that this is also true. If we want this inequality and this equation to be true at the same time, that can only mean the limit as x goes to c of g of x must equal the limit as x goes to c of h of x and the limit as x goes to c of f of x. This theorem might seem pretty random, but it's really helpful in helping us solve certain kinds of limits, like this one. How the squeeze theorem comes in is we're going to use the properties of sine. Remember how the sine wave always bounces from +1 to -1 to +1 to -1, and it exhibits this behavior no matter what's put inside of the sine function. So we can say that sine of anything is always between 1 and -1. And in this specific problem, we see that we have 1 over x squared inside sine. So I'm going to put a 1 over x squared in here, like so. Our goal is to get this thing in the middle exactly like what we're trying to find the limit of. To do that, I'm going to multiply 4x cubed to every part of the inequality, like so. And now I'm going to take the limit as x goes to 0 of all three parts, like so. We know that negative 4x cubed and positive 4x cubed are both continuous functions, so we can direct substitute 0 to evaluate this limit. Direct substituting yields that both of them go to 0. So now we're presented with the fact that this limit is less than or equal to 0 and greater than or equal to 0 at the exact same time. So this can only mean this is equal to 0. And that's how we use the squeeze theorem. And to close the video, I'll leave you with these 3 special limits that College Board wants you to know for their AP exam, all of which can be proved using the squeeze theorem.